I'm Yixuan Li, and I'm going to do this presentation with Vincent Xiao, and our topic is Review of Electric Propulsion in CubeSat. Propulsion systems are very important if we want to extend the mission lifetime of satellites or that the satellites perform more complex missions. There are many propulsion system options for us to choose from, but in this study, we'll focus on electric propulsion. Electric propulsion generates thrust and alter the velocity by electricity. Based on how they generate thrust, we can divide them into three categories, which are electrothermal, electrostatic, and electromagnetic thrusters. This is how we conduct our research. We'll first look at background theories and analyze their functions. And last, we'll do the assessment. We will analyze current models and calculate thrust with equations. Because energy and power budgets are very important for CubeSats, and different CubeSats have different power budgets, so we'll set 3U CubeSats to have 8 watts of power and 6U CubeSats to have 16 watts. First, I'm going to introduce the electrothermal thrusters. Electrothermal thrusters use electricity to heat up the propellant and exhaust the heated propellant through the expansion nozzle. Therefore, they share the same thermodynamic principles as chemical thrusters, and we can calculate their thrust with the following equation. We will analyze 2 types of electrothermal thrusters in this study, which are resistojets and arc jets. And this is the thrust analysis of electrothermal thrusters. We can see that when provided with the same amount of energy, resistojets generate much more thrust. This is not because it has less propulsion time, but also it has more efficiency. Next are electrostatic thrusters. Electrostatic thrusters are propelled by the potential difference between the anode and the cathode. Therefore, we need to change the voltage. Why? Because normal satellites only have a few volts, generate a few volts. However, we may need a few hundred volts or even a few kilovolts to have enough potential difference between the anode and the cathode. And in this study, we will make them use DC to DC converters. We will analyze 4 types of categories, 4 types of electrostatic thrusters. The first 2, gridded iron thrusters and Hall thrusters, will consume all the energy we assign. The last 2, electrospray thruster and field emission electric propulsion, abbreviated as FEEP, will only take 1/1000 of the total power. This is the thrust analysis of electrostatic thrusters. We can see that those 2 thrusters that take all the energy, they generate different thrust. Why? Because even though they use the same type of propellant, they still differ in voltages and currents. Because Hall thrusters usually use a few hundred volts, while gridded iron thrusters use a few thousand volts. And on the right table, we can see that the electrospray thrusters and FEEP have different thrusts as well. Even though in this case, we assign them the same amount of energy and even the same amount of voltage, same number of voltages and currents. This is because they use different types of propellants. And we can see that electrospray thrusters generate more thrust than FEP, even though they only generate a few micronewtons of thrust.
对，让我看不到你们分享的画面，那我就继续讲了。我可以继续讲。我其实看不到你们分享的画面，但我可以继续讲。
好。我拿换页。他看不到在左边吗？
我是看不到你们的画面的。
喂？
那不然我继续啊。
对。
The electromagnetic thruster is using the Lorentz force or magnetic force to accelerate the propellant. It has 2 categories, which are the pulse plasma thruster and the magnetic thruster. In the MPDT, we can see that it is using the magnetic pressure effect and the magnetic nozzle effect. Inside the thruster, the magnetic field controls the plasma, which is making the plasma particle circle in the thruster, and then we turn the swirling energy converted into exo energy and expel the particle with the divergent magnetic field. However, the methodology we used for previous two types of thruster cannot work for electromagnetic thruster because there are many dependent variables such as radius and configuration which affect the magnetic field, and the RLC circuits which will affect the impulse frequency. So we will study the thrusters from nowadays. For the power between 8 to 15 watts, the typical thrusters are about micronewtons to millinewtons. After the analysis, we will talk about the assessment part and the conclusion part. Every thruster has its characteristic. Whether it is a good thruster is depending on the mission requirements. The higher thrust can accelerate the spacecraft faster, and a higher exalted speed allow the spacecraft to reach higher speed and delta V. Nevertheless, the main point is CubeSat requires low power consumption. This makes electromagnetic thrusters hard to implement because of its high power consumption. It generates both electrical field and magnetic fields. The simplest type of electric propulsion is the electrothermal thruster, and it can produce strongest thrust. The electrostatic thruster has lower thrust that is suitable for altitude control. And it is hard to analyze the electromagnetic thruster. The methodology should be improved for analyzing this kind of thruster. And that's all for today. Thanks for your listening.
Thank you.